All right, so we will continue where we left off the last time, where we had started discussing about the basics of JavaScript as a programming language, and we were talking about different constructs of a basic programming language, but rather than learning it again in the traditional languages like we have done before, we were just discussing about the syntaxes that JavaScript uses in order to implement those basic constructs, right? So what we are going to do today is cover the rest of the basic syntaxes in the form of learning how JavaScript essentially is used to implement conditional statements such as the if-else statements. And then we will talk a little bit about how functions are implemented in JavaScript. The notable thing about functions is not just the syntax for traditional function implementation in JavaScript that we are going to be focusing on, but there is a certain syntax in JavaScript that is used for the implementation of functions that is known as arrow functions, right? So we're going to talk about those arrow functions because that is the current standard of notations for writing functions in JavaScript, and we will be using that quite often when we will work with React.js and then going into React Native and stuff like that. We will also talk about loops, how to implement loops in JavaScript, specifically talking about for loops and while loops and stuff like that. But it's the for that we will use quite often. And then finally, we will kind of discuss about things such as arrays a little bit, because there are certain methods on arrays which helps us to kind of go over, traverse, do our processing and operations on a collection of similar units, right? So similar data types of values that we want to collect. We can also choose to have different data types if we have an array of objects and stuff like that. So through arrays, we are going to kind of look into how JavaScript syntax helps us kind of implement those operations. And then finally talk a little bit about object literals, because that is one of the most important or most frequently occurring things that programming constructs that we are going to be using in JavaScript as well. Okay, so once that is done, the roadmap for the future lectures, if time permits, today itself or the future lectures, will be to kind of demo two different prototypes for JavaScript projects specifically. And the goal through those demo is to more importantly, learn about DOM manipulations, okay? DOM, as it stands for Document Object Model, represents the tree structure for any kind of web application, right? So through DOM manipulation, we will understand how we can bring forth dynamicness and interactivity to the static websites that we had learned to develop using just plain HTML and CSS. So those two demo projects that we're going to be doing is the first and foremost, the first one is the very popular and the beginners JavaScript project that we should all kind of learn to implement, is how to build our own calculator app, right? And then this gives us a very good insight into a few things that is JavaScript. So of course, the first thing is about DOM manipulation. So it will teach us how to select different JavaScript or different elements on our web page, and how to pull that element into our JavaScript file or scripts itself, and then kind of do some processing on it and return the output back to the web page itself or render it back onto the browser, right? So in doing this, we are also not just going to understand and get familiar with the implementation of JavaScript, but we will also revise some of the previous concepts that we have already covered in the form of CSS and HTML. Specifically speaking, in CSS, we are going to be learning about grid display, right? So this is the only form of display that we have not touched upon yet. And building the calculator app gives us a good scope to kind of get familiar with how the grid display CSS property works. And then we can learn more about that. And the second project or the second demo that we are going to be doing in the domain of JavaScript is basically a rehash or a revision of what we have already done in the first project, which is the calculator app. But this time, we are going to be implementing what is called a quiz app, right? And it will be like a clone app for popular online quiz application or platform that is available that is known as Kahoot, right? So some of you might be familiar with it. Otherwise, you can check it out, what Kahoot is. And then we are going to build something very similar for ourselves as well, using just HTML, CSS, and JavaScript in order to revise the concepts that we have already covered in the first demo and what we are doing right now. Okay, so that is basically the agenda for the upcoming 2 or 3 classes that we are going to be working with, right? So starting first with conditional statements. So we have already learned that the way to declare variables is by using scopes, right? So we talked about the fact that there is no strict data types like we have in, let's say, Java, C, C++. JavaScript kind of inherits, so to speak, in a pseudo-technical term, the data type that you assign it to. So that means if you have a variable like age, and if you assign it to, let's say, a number 21, right? So then the data type of the variable, due to this assignment operation itself, makes it number or numeric, right? So there is no distinction between an integer and a floating point value in JavaScript language, right? But the way or what you do specify for the variable during its declaration is basically what is its scope. So in which part of the program can it be used? Can you reassign the variable's value and things like that? So the 2 specific scope operations or the scope operation that we specifically use or you would want to use in JavaScript is the let scope. And let basically makes any variable declaration local to where you declare it, right? So if you declare it at the beginning of the program, then the scope of this particular variable that we are working with is going to be local to the entire program lifecycle, right? And in the case, if you declare a variable with the let scope, right, within a particular programming construct, that could be, let's say, within the body of an if-else statement, or within the body of a for loop, or within the body of a function, then the scope of that variable becomes local to that programming construct wherein you have declared that particular variable using the let scope, right? So that is the first operation, or that is the first type of variable declaration that we will be seeing very often in JavaScript. And the other one is basically to declare your variables as const, right? Which kind of establishes the fact that you can declare the value of this variable once in the program, but you cannot reassign the value of this variable, right? So if you, using this understanding, if you want to write, let's say, a very simple if-else statement, or not an else statement, but if you're just going to write an if statement, okay, you can declare, let's say, a variable as const, and then you can say let user age is equals to 21 or something like this, okay? And then in order to write the if construct, it's just if, okay, followed by the condition, and then within the curly braces, you write the logic of the body of the if, depending on the condition. So that means if this condition is true, then what are you going to execute essentially, right? So here, what you can do is user age, if that is equals 21, right? Here you can basically do a print statement. And remember, the print statement in JavaScript is console.log. And within that, you can write it as, let's say, a template string. So in order to write it as a template string, you use backtick operators, right? Or the backtick character, and then you can simply write the string, right? So that means you can say that, let's say, the user whose age is, and then anytime you want to kind of refer to any of the values within a template string, you just simply write the $sign followed by curly braces, and then refer to the number that you are essentially trying to use here, whose age is this, is approved for the loan, something like this, right? So if you want to give a custom message and stuff like that. So this is basically a very typical construct of an if statement, right? So all the operators, so this is known as the condition, right? You're all familiar with the part that this is the condition, and then you can kind of combine different conditions as you are familiar with in other programming language. So all of the comparative operators that we use is also used here in JavaScript as well. So that means you can use the greater than, you can use the less than, you can use the greater than equal to, you can use the less than equal to, and all those stuff, and where the double equals is the equal sign, right? But in JavaScript, there is going to be a little bit of a difference with respect to the fact that there is not just a double equal sign, and in comparison to other programming language, JavaScript also supports another comparison operator, which is the triple equals, right? So this is one of the unique aspects to JavaScript programming language compared to the other traditional programming language that you can have there, right? So to understand, the other stuffs are basically kind of intuitive, and we don't have to go over them, but we basically have to just touch upon a bit about the differences between the double equals and the equals, triple equals operator. So let us just complete this if with an else part, right? So generally, if else statements have an else part as well. So for the else part, we are not checking any kind of chained logic. So what I mean by that is that we are not doing an else if, that is known as the if else if chain. We are just doing an alternative in the case that this condition that we have written fails, right? So let's say we just do the opposite of this console log that we have here, and we can simply say is not approved for the loan and something like this, right? So you can, to check the output, you can either chain this or you can basically link this script that you have with the index file that we have for HTML. So just to keep in mind, in order to link any of the index files or any of the script files that we write to our HTML file, what we do is basically within the head tag of our HTML, and this is basically a revision of what we have already covered in the last class, we use the script tag with the attribute of source, and then we need to essentially find the file where our JS file is, right? So right now we are in the root folder. So that means I give the // go to the subdirectory for JS, where we will have all our JS files, and then we will just give an index.js. The other attribute that you would want to use is basically known as defer, which basically prevents or delays the loading of this JavaScript index.js file that we are linking with this HTML after it is done loading the body of the HTML page. So this is how essentially you are going to link all your JavaScript files to your web design or your web app that you're developing. But just for this particular use case scenario, that is where we are just getting accustomed and getting used to all of these different basic programming constructs in JavaScript as a language. If you have Node.js installed, basically you can execute this JavaScript program within the terminal itself outside of the browser environment. And we had discussed how that is possible in the last class, right? So what I'm going to do is simply just use Node.js for the time being, because this is not some JavaScript that is basically manipulating anything on the index.html or its corresponding pages that we have for this particular project, right? So right now you can see that we are in the root folder. So all I need to do is basically go into the subdirectory where my JavaScript file is, and then simply just type node and then index.js. Okay. So here we can see that the user whose age is 21, that is pretty obvious, right? Because we assigned 21 and we are checking if the age is 21. So if you give any other value here, so for example, let's say 20, and then rerun this. So we can see that the not approved message or the else part of the if else statement is basically executed. That is pretty straightforward. But let's say if we put the value 21 and here, instead of giving a number again, what happens or what do you think will happen if we put a string value of 21? So let's check this out. So if we run this, you can pause this video at this point of time for those who are going to watch this offline, and those who are in call, you can think about what this output is going to be. That is it going to return us the body of the if statement, or if it is going to return us the body of the else part itself, right? So let's execute this and let's check out what happens. And you can see that the if condition holds true. So this is where that distinction between the double equals and the triple equals comes into the picture, that when you are just working with double equals, it does not check the data type of the left-hand side and the right-hand side, right? So what it does is just it only compares the values. So to get an understanding of this, we know the fact that when we declared this variable, we assigned a number data type to this variable, right? So that is what the left-hand side of this logical condition is all about. However, on the right-hand side, you can see that the value that we are comparing it with is basically has a data type of string. Okay, so essentially what we are comparing here is a number to a string. Okay, however, since we are using just the double equals, then essentially what JavaScript interpreter is doing, it is ignoring the data type of the left-hand side and the right-hand side of the equation, and it is only checking for the value itself. So that means if I change this string 21 value to, let's say, string 20 value, and let's say we rerun this again, then we can see that the else part is basically executed, and the if condition results as or evaluates to a false, right? So that is basically what is happening. But however, let's say if I do 21 again, and we have already seen this, that the if condition will be executed. If you want to compare, so if you want to compare both the value and the data type, okay, so then you have to use the triple equals. Okay, so in this situation, let's say if you execute this particular code again, then you can see that the else part is now executed, because what is happening here is because of the triple equal sign, it is going to compare both the value and the data type. So the value here is 21 and the value here is also 21. That is correct. Okay. However, the second condition that needs to be evaluated is that the data type must also be the same for LHS and RHS. But you can see here that the right-hand side data type is basically string compared to the left-hand side data type, which has been assigned to a numerical value. And as a result of this, this entire condition basically equates to a false, and then the else part gets executed, right? So this is the first difference that you have to keep in mind. And this is something that you will see when writing conditional values or conditional statements, is that when you are using the equality operator, if you simply just use the double equals, then JavaScript is only going to compare the values and not the data type of the left-hand side and the right-hand side. So if you want to compare both the value as well as the data type, then you need to use the triple equals, which is a more stricter form of your equality conditions. Okay, so here at this point of time, you can kind of chain all of the different values. So for example, if you want to find out, let's say if the user age is equals to 21, you do something, okay? And then let's say if you want to have another condition, and then let's say we can put it here, okay, we can chain it here, and we can say else. And then if you want to chain it, you simply write another if statement, okay, where you can say something along the lines of else if user age is less than or equal to, let's say, 25. Here you can give another console log message just to kind of imply certain operation. Okay, so you can just copy this, put it here, and then you can say is can take a discount on the book, something like this. And then you can finally chain this whole condition together, where you can simply say that the user can basically, or the user is not approved for the loan because their age is not 21, or their age is not less than equals to 25. Well, this will run true itself, but you can come up with a better logical if else condition here if you would want. Okay. So another thing to keep in mind, in addition to this if else if chain that is kind of pretty similar to what you do in other programming languages, is the ability to kind of chain multiple conditions together, right? So for example, we know that so these are all the comparative operators, right? So there are also logical operators. And the whole purpose of logical operators is to kind of chain multiple conditions, logical conditions together, right? So there are three different types of logical operators that we are familiar with from other programming languages, if you remember. Is the fact that we can either use the what we call as the logical AND operator, or we can use the logical NOT operator in order to flip a bit, okay? And then we can use the logical OR operator, and then we can combine some of these operations here to kind of chain multiple conditions together. So the symbol or the syntax for the logical AND is kind of pretty similar to what you are familiar with in Java or C and C++, right? So you use the double ampersand operator to kind of represent the logical AND. If you're working with the logical NOT, you just use the exclamation, right? And then for the logical OR, you simply use the double pipe operator, okay? So this is what we call as the pipe operator, or the pipe character, whatever you want to call it. And then you can basically combine multiple operations or multiple conditions together. So for example, this just flips the evaluation of the truth and false values. So if you want to evaluate, let's say, something equal to not equal to, then you can simply use this. So this will stand for not equal to, okay? But remember, again, as we talked about, the fact that when you are evaluating equality, there is always a double equals and then there is a triple equals. And we just talked about the difference between the two. So if you just do the not equals to, then it is just going to compare the values, and again, not the data type. So that means if you want to compare both the values and the data type with the logical not operator, then you have to give a not and then double equals. So basically, we are replacing one of these equals with the logical not operator. Okay? And then that is how you can kind of chain different values together. So as a self-exercise, what you can try is probably implement or write a conditional to check if a value is between 5 and 10, right? So you can check something like this. So try this out by yourself with this understanding of writing if-else statements and with the knowledge of all the operators that we just talked about on how you can implement to check if a certain value is within a certain range of them, right? So try that out. That is one of the basic exercises that we do when we are working with conditions as and stuff like that, okay? So in addition to this, when you are working with conditional statements, there is also another operator that we are going to use for writing conditionals. Basically, what we call it as when we work with either JavaScript or React.js and so on, is to write conditional rendering operations, right? So this gives us the ability to check that if a certain, let's say, event has happened, or if the user provides us with a certain value in a field that you're showing it through the browser and stuff like that, then you would want to display a certain aspects on your web page. If the user does not provide that value, then you would want to probably show a different aspect or render a different aspect on your web page, right? So of course you can do that using a if-else statement, right? But the goal here in terms of using the term ternary operator is to basically kind of reduce the code base and make it look a little bit more abstract, but cleaner at the same time, right? So the way you want to do it is ternary operator basically operates similar to a function. So that means the way we will see is the way when you write the syntax, it basically returns you something. So you want to do something based on that. So what you can do is something like this. So let's say we do another declaration of, let's say, user age to vote, right? And let's say we put 17, something like this, okay? And then we want to kind of output the fact that whether or not, given that this is the user's age, can the user vote or not, right? So if you think about it, the logic is pretty similar to what we discussed. If you want to write this as a traditional if-else statement, you can try this out right now by pausing the video whenever you're watching this again, is you can check if the user's age is, let's say, greater than or equals to 18. If that is the case, then you can console log and then you can kind of print the message that, yes, this user is allowed to vote. Or you can give an else part, right? And then else, you can simply just say that the user is not capable of voting, right? So instead of writing, let's say, 3 sentences here for the if part, and then maybe the else part, 3 sentences here, counting for 1 sentence for each curly braces. Instead of writing that many sentences, what you can do is, let's say you can create another variable, and this can be like a Boolean variable that is going to store the output of whether the user can vote, given that this is the variable that is kind of holding the value of the user variable. And the way you write the ternary operator is first you essentially write the condition itself, right? So the condition that we want to evaluate is basically we want to compare this. It just removed all of this. Okay. And all we want to check if this user's age is equal to, greater than, or equal to 18. Okay. The next part of the syntax is a question mark, right? So the question mark generally implies that what happens when this condition is evaluated. So when this condition is evaluated, this question mark indicates what you want to do. Okay. So if the fact that the user's age is greater than or equals to 18, then what is the truth value? That is the first thing that you want to write. So we want to specify the fact that the user is able to vote. So we want to store in this variable the Boolean value true. Okay, so this is a Boolean variable itself. And then the next part of the syntax in the ternary operator is basically a colon. And after the colon is where you write, what are you going to do if this condition evaluates to false? So here in this particular use case, it's simply going to be a false Boolean variable, right? And after that, you can simply just close this. All right. So prettier you can see as far as the documentation is concerned, it does not put the parenthesis around the condition if you're just evaluating a single condition. But let's say if we console log this and then we just want to put this variable here. Okay, so this should show us a false value, because if when you evaluate this, the value inside of this is 17 and 17 is not greater than 18. So it does not execute the true part of this ternary operator. It is typically going to execute the false part of the ternary operator. So here we can see that we get a false result. So what typically happens is, and this is you're going to be seeing in React.js quite often, is that you evaluate, let's say, a value that you capture from your website here, and you check that condition, whatever you're trying to evaluate in terms of your implementation logic. And here, instead of, let's say, putting a true value or a print statement, you render something on the web page based on whether the condition is true, or you render something else on the web page based on the condition being false, right? So essentially, instead of writing a 6-sentence if-else conditional statement, you can basically finish that whole code with a single line, right? So that is basically the importance of getting accustomed with the ternary operator. Okay, so again, to kind of simplify the overall syntax, make it a little bit more generic, you essentially evaluate a condition. The condition is going to be either true or false. Then there is a question mark, which kind of implies what will happen after or as a result of the evaluation of the condition, and that can be either true or false. So you write the truth, whatever the truth condition is, or the execution of the truth part is first, followed by a colon, and then you write the false part of whatever you are going to do if the condition evaluates to false. So this is basically the syntax, and this can return something to you as well, right? So that means that you can assign the output of either the truth or the false to a variable itself, right? So that is what you have to keep in mind. So this is how you essentially work with ternary operators. And the last part of conditional statements is basically the ability to write switch case statements. Okay, and we are familiar with switch case statements as well from other languages. So this is going to be a breeze as well for those who are familiar with it. So let's say you define a menu choice. So you can say you have a menu choice and the user, let's say, chose a menu of 2. And assume that this value is coming from the client's interaction. I'll show you exactly how you want to kind of grab that information. But let's say to fill in the blanks for the time being, let's say you provide through your web interface, the users some option to choose, right? Some menu to choose. And this is something that you can find quite often when you are developing, let's say, some kind of takeout website or some sort of, let's say, food delivery application and things like that, right? So maybe you want to render something based on the user's selection of a certain menu choice, right? And you have coded what those menu choices are. So now, if let's say you have 2 or 3 different options, okay, with respect to the menu choices, the traditional way of implementing this is through this if-else-if instance, right? So you can continue chaining your if statements and it will keep on evaluating. The problem with writing chained if-else-if statements is that regardless of whether or not, well, not the chained one, but if you write it in an unchained manner. So what I mean by that is, let's say first I evaluate this if, and we check if the choice is, let's say, this is not syntactically correct, but this is just to give you the idea of the pseudocode. So you do, if choice is this, then do something here, and then you can write another if choice is, let's say, 2, then you will do something here. Okay. The problem with writing it in this way, that is an unchained if statements, one after the other, basically trying to implement the logic of a selection. Okay. The problem with this is, let's say, even if this choice 1 becomes true, then this body is what you want to return or what you want to execute, right? But what happens in terms of implementation is that the interpreter will continue to evaluate the rest of the choices as well, because there is no correlation between these, right? So that is the problem there, is that, you kind of evaluate unnecessarily the other choices when you have already found the choice that the user has selected, and you have found the corresponding body of that conditional statement that you would want to execute, right? So that is something that you don't want to code in such a way. The alternative to this is, instead of writing it as unchained if statements, you can just right after the body of the first if, you can do else if, and then pull the condition this, and this will continue till the point where you can simply write it, or the final block will simply be a else statement and not an else if else if statement, right? So this is basically the if else chaining. So this will stop the corresponding evaluations of the other if statements, right? However, what you have to keep in mind is that you will have to, of course, write more codes, right? More sentences of code, and you can reduce this, right? And the evaluation is always dynamic in nature. So that means in terms of execution, your interpreter has to go through each of the conditions, check each of these conditions as it encounters them, and then figure out which condition is true or which condition is false, right? So that takes more time in terms of implementation. So there is a better way to implement such use case scenarios where the interpreter can basically, when your page loads or something like that, or when your program loads, the condition is evaluated only once, and there is basically this mapping of what the condition being true or false, or whatever the condition is, and what body needs to be executed based on that at the very beginning, right? So it is kind of there from the very beginning. So it's mostly like using a reference, okay, where you know what your reference table is like. So if somebody comes and tells you that, hey, my age is this or that, you already know what to do with that. You don't have to evaluate each and every person, right? So the amount of time that it takes to kind of execute that is much less compared to writing a chained if-else-if conditional statement. So the syntax for switch case is basically you have the switch statement itself, or the switch keyword, followed by the condition that you're trying to evaluate. So in this situation, the condition that you're trying to evaluate is if the menu choice is triple equals to, again, to revise, triple equals evaluate both the data type as well as the value. Okay, so always use a stricter form of the equality operator in JavaScript if you want to evaluate both the values and the data type itself. Otherwise, you might make a mistake where you compare a string value with a number and it passes through your conditional check. Okay. After that, what we have is quite similar to the traditional programming language. We have the case keyword, and each case keyword is separated from each other with a break statement. Okay, so the break basically allows us to break out of the switch case body. Okay, whenever a case becomes true. So here, the value of the cases will be all of the different values this variable can assume. So let's say we have one case, which is menu option 1, and let's say we have another case, which is menu option 2. So let's say you are giving the user 2 options, okay? And then the switch case statement will always have a default case, which essentially means that if the user gave input, which is not any of the cases that we have seen before the default case, then what are you going to do? So if the user is not selecting, let's say from a drop-down menu, if the user is entering their input, right? So they can write something that is not 1 or 2. So that means if they write something like 3 or 10, then how is your code going to handle that situation, right? So for those scenarios, you have a default case followed by a colon where you write the body of your code. And then you, of course, have a break statement. Remember, if you don't have a break statement, it will continue to treat all of the corresponding cases with the first case where you have forgotten the break. So that means if I miss the break statement here, anything after this line of code from 29 onwards will, until it hits another break, will be treated as a part of the previous case. So that is the reason why you would want to have a break statement after every case. So for example, let's say if you have selected menu 1, then you can probably give a console log here, and then you can say you have selected, let's say a salad, right? And then you can break it down, and then here you can give, and you can say you have selected a burger, something like this, right? And the default statement, you can write something like you have selected an incorrect menu option. Or you can say, sorry, we do not support that menu option here, or something like this, right? So if you save this, this is how the entirety of our switch case construct is going to look like. And this is pretty useful, as we said, when we are working with the users with respect to input that they provide, and that corresponds to multiple selections that you can work with, okay? The next thing that we want to do is basically loops, right? And loops, I think before we get to loops, let us talk about arrays first, and then talk about loops, because we need something to iterate over before we can actually discuss loops. So we will come back to arrays and loops together. So let us just talk about functions before we get to loops itself. So we will kind of delay loops, because we will discuss it with arrays itself. That will give us the opportunity to kind of implement our loops on top of the arrays and make it easier for ourselves, okay? So we will talk about this in a bit after we discuss about functions, all right? So functions is going to be one of the most important components in JS, not just because, you know, you're going to design your programming logic in a modular fashion, right? You're going to be using functional programming paradigms in React.js, right? Because after, I think, 16.8 version React.js from class-based development, it has moved towards more functional-based development, right? So this is something that you need to be very familiar with, right? So just to give you a quick crash course on functions, just to, you know, jog your memory, when you are prototyping a function, that is what we kind of refer to when we say that we are declaring a function. In a typical programming construct, okay, you have a return type of the function, which kind of indicates that what value this function is going to return. So let's say if you write a function as int at the very beginning, so that is what the function is going to return, right? This is what happens in Java. This is what happens in C, C++, stricter programming. If the function is not going to return anything, then the return type we generally specify is basically void, which is to imply the fact that this function is not going to return us anything. After specifying the return type, okay, we specify a name for the function, right? A label or name for a function, which is going to, when we refer to it, it is going to be replaced by the body of the code that needs to be executed, or wherever that function is stored. The accumulator is basically, or the program counter is basically going to move to that address where the body of the function is, the code block is stored, and then it will execute everything. And then when it hits the return statement, the program counter jumps back to wherever the function call was made, right? So we need some sort of label or some sort of reference to wherever that memory location is, where the body of the function is. So that is indicated by the name of the function. Now, then you have the opening and closing first brackets, which kind of indicates that this name or this label is not like a variable, but it is actually a function. Within the first brackets, you have the capability to specify what we call as parameters. So that means when you call a function, you can pass in some values to it, right? And then wherever the function body is, it will accept those values, plug it into its function body, and do the processing using all those parameters, right? So you have the capability to kind of specify any number of parameters for your functions, okay? The difference being when you declare the function, the portion of these values within the brackets is called parameters. When you call the function, these values are referred to as arguments, right? But essentially, depending on the way you are calling the function and what programming languages support function call, the different types of function call, because depending on the language, you can either have a call by value type function call, or you can have a call by reference function call, right? So something that you need to kind of remember if you've forgotten about these two. After that, you have the opening and closing curly braces, okay? And then within the curly braces, where you write the logic of the function body, here you can declare your own variables. Again, that will be local to the function body if you don't want to use it outside of the function, right? These parameters are also local to the function body. That is something that you have to keep in mind. And after that, the last thing in the function is going to be a return statement. And this return statement will essentially return the program control back to wherever the function was called. So this is basically how you prototype the function, okay? Now, after prototyping the function, you have to call the function as well. So here I would just say typical syntax or generic syntax of function prototyping, or simply called as function declaration. Okay. And then you have to call the function somewhere after declaring it. So when you call, or otherwise better known as invoking or executing the function, you simply call the name of the function. You don't specify the return type. You call the function name and then pass in the argument. So let's say 2 or 3, whatever that argument is, or if it's stored in a variable, then you are going to use the variable. Now, if the function is going to return you something back, so let's say if this is going to return back an integer value, so that means we need a storage location where we are calling this function in order to save the value that will be returned by this function body, right? So here we can do something like int for other languages. So you can just give data type variable, and then we can give the function name here, right? So this is typically how functions work, right? And you can give the semicolon. Now, if you try to correlate to the changes that you need to make to this generic syntax or the traditional syntax that you're familiar with in function calls, you have to remember that JavaScript does not use any data type specifier when working with declarations, right? Whether that declaration be a variable and whether that declaration be a function name itself, right? So that is what you have to remember. So what we do is, instead of specifying a return type with a data type itself, the way we declare a function in JavaScript is basically just use the keyword function followed by the name and the parameters and then the body of the function. That is it, right? Very simple. So that means we just give the name of the function. So that is where the function name comes from. There is no return type. Instead of the return type, we simply specify the keyword function. So this is a reserved keyword. Keep that in mind. You cannot use this in a custom way. And then within the brackets, you specify the parameters. So let's say if we are writing a function which is going to add two numbers. All right. So the parameters that we are going to be receiving is going to be, let's say, something like input 1, comma, input 2. So this is what the user is going to specify. So again, remember, the reason why we don't write something like int input 1 or int input 2 is because there is no data type specifier when declaring variables or function names in JavaScript, right? I do not have to specify the scope either, right? The reason behind it is because whenever you write a parameter for a function, that parameter is considered to be local to the function itself, right? You cannot use it outside of the body of the function, okay? And then let's say if you want to write a console log here and you want to perform some operations, so we can use a template literal again, and we can say the sum of the input values are, and then again, $, curly braces in order to do operations outside of the string, right? And then we can say input 1 plus input 2, something like this, give a semicolon at the end, all right? And then kind of stop here itself, right? So we don't have a return statement, which is kind of one way to put it. If you wanted to redo this, and if you wanted to send back the value of this variables, addition of these variables, back to wherever the function was being called, then you would simply write return within the body, and then input 1 plus input 2. Yeah, this is a very simple function, so we can just do it in one line. If not, then we will have to break it, right? But if you do something like this, right? So that means wherever you call the function, you need to have a variable that can store the value that will be returned by the function. So that means currently the way this function is written, this is not encountering any return statement, right? So it is not really showing anything. It's just printing out the statement itself, and then basically the program ends here. So if you execute this, you would simply call the name of the function in order to refer to the function body, and then you will pass in the values here. So let's say we do 3, 5, and essentially this should give us 8 at this point of time, right? So now if you clean this up and execute this program, then it does not show us anything because I have not saved it. Okay, so here you can see that the values that we return, which is the body of the function, is basically 8. However, if let's say I change the code here, right, and I, instead of putting a console statement, I put return input 1, input 2. So that means I have to have something like a const, and then maybe not a const, because this might get reassigned a lot. So maybe we can say let output variable is equals to add 2 numbers, and then we can print the fact that the output of addition is $, and then here we can put whatever value is here inside the output variable. We can just plug this in, save it, and then run this again, right? So here we get the output of addition is 8, right? So the two things that you have to keep in mind is anytime you put a return statement, what is important is that you specify wherever you are calling the function itself, basically a container that would be able to store whatever this return statement is giving you back. So that is something that is important. There are also ways in which you can kind of put default values to your parameters. So all you need to do is input 2, and then let's say input equals 6. So what I'm doing here is I'm not just only declaring my parameters, which is, by the way, local to the function. Again, keep this in mind. The scope of these variables are local to the function add two numbers. I'm also assigning values. So these are known as default parameters, because in case, let's say now, I do not provide any values here, right? So what is going to happen is that we don't provide any parameter values when we are invoking the function. So this function will basically execute with whatever values input one and input two has. Remember, when we discussed about variables, if you do not assign any values when you declare a variable in JavaScript, then the data type of that variable is going to be undefined. So that means if we didn't have these default values and we left this arguments empty when it is expecting arguments, then you would get something that is undefined. This will basically break the program, right? So we can test that out real quick in order to kind of do a sanity check. If we run this, essentially, this should break the program, right? So this says that the output is not a number because we are trying to add an undefined with another undefined, and essentially that is not a number. However, if you do something like this, so if you add 2 here, and let's say if you put 4 here, so this is a function declaration where the parameters have a default value. So that means if the user does not provide us with a value, then it will assume the default value. So there are cases where you can essentially do that as well. So now you can see that instead of getting not a number, we are getting the results of the default value, right? And you can always kind of like overwrite the default value. So anytime a user is going to provide any values, that will essentially overwrite the default value itself, right? So instead of doing 4 + 2 is 6, it essentially gives us the values that the user provided, which is 8 + 5, that is 13, right? So that is the fun part of it. But what we have to actually learn here, this is pretty simple, right? But what we need to actually learn is how to essentially rewrite these traditional functions in JavaScript using the arrow notation. Okay? And because most of the code bases that you will come across, they will be using a lot of these arrow notations and stuff like that, right? So knowing how to write the traditional way of working with a function is important, but more often you will see that people will be using arrow notations, okay? So what the arrow notation does is, if you want to generically understand it, okay, the typical syntax of the arrow notation will look something like this. So you will see a first bracket, okay, and then you will see this arrow, okay, and then after that you will see a curly braces, which will basically be the logic or body of the function. So that is basically all there is to an arrow function. Okay, so what happens is that if you do not have any parameters, then this block is going to remain empty. So what this is kind of signifying is this portion of your function declaration. That is what parameters is going to be there, okay? Then that parameter, this arrow notation is saying, take that parameter and then push it into the logic or the body of the function, which is basically this part here, whatever this part is. And if your body is just a single statement, for example, here we just have a single return statement, you generally will not see the curly braces either, right? And since this whole syntax is a function similar to what we did in this ternary operator, then this is going to return something back, right? So just like a function, just like the ternary operator, we saw that it is either going to return true or false. So we have the ability to capture that value in a container like a variable. Similarly, when we write this arrow notation function, you have to remember that if your function has a return statement within the body, or if the body is basically a single return statement, then this is going to return back something to you, right? So that means you have to be able to capture variable output, that value with the function. So this is what the generic syntax of the function is going to look like. So now if you want to, let's say, convert this function that we just wrote using the arrow notation, what do you think it's going to look like? Take a wild guess, take a moment for those who are new to this, okay? Think about it for a second, that how would you convert this line to this line, that is 55 to 58 that you have, and rewrite it using this notation. So this is just basically a syntactical change in order to reduce the code base. So all this is referring to, you first start from this portion here. This is the parameter. The arrow notation says take the parameter, push it into the body of the function. And then if the body of the function is going to return something back to us, then essentially store that in this variable. So whenever you have to call this function, you are essentially going to call the function using the name of this variable and then pass in the values here. So first of all, we will come to the invoking part of the function itself, but think about it. How are we going to write this function here with this notation? Just focus on the part which is highlighted right now on the screen. So you can pause or you can try it right now. Think about it if you're doing it right. And this is how it is going to essentially look like. So again, within first brackets, we are going to write the parameters of the function itself. So here, what are our parameters? So we have two inputs. Okay, so we are going to write input 1 and input 2, not like this, but like this. Okay, so now we have taken care of the parameters itself. All right, so we have input 1 equals to 2, input 2. And then this needs to go into the body of a function. And the body of a function is basically a single return statement that gives us return input 1 plus input 2. Now, for single statements, you don't need a curly braces. Typically, you need a curly braces when you have a function body that spans more than one line or one sentences. But just for the sake of practice and making you all be familiar with the fact that the curly braces is nothing but signifying like a compound statement of function body, we are going to keep that, right? But what we have is basically a return statement that is going to return input 1 plus input 2. Okay, so that is all there is to the function declaration. So this is all the function declaration that is there. So now you can compare this, that instead of writing the function keyword and then giving it a name itself, we can simply just reduce the extent of the syntax that you have to write to a little bit, right? Now, since this is returning something, we have to look at the invoking of the function itself, or where the function is going to store it, okay? So we need to store it, and let's say we call it output of addition, okay? And then let me just kind of comment all of these things out, all right? And this output of addition is what will hold the value of the return statement, okay? So this is basically the assigning of the function's output to a variable. Now, this is all about declaration. So how do you invoke this function itself? So the way you invoke this function is by using the name of the container, which is going to store the value itself. And then within brackets, just like we did here, we provide the parameter inputs, okay, or the arguments of the function. So what we are going to do here is something like this, that using the arrow notation for functions, the result of addition is, and then again, since this is template literals, you use the $sign and then the two brackets around here. And then within this, you are going to first call the name of the function, the label that is going to store the output. And then since this has a parameter, if you don't give any parameters, remember, since we have a default value here for the parameters, it's going to return a 6. So if you want to provide your own values, then put a first and say opening and closing first brackets. And then you can essentially just put whatever values that you want to place here. Okay. So this looks a little bit weird because of all this arrangement, but you get the idea of what we are trying to do. So maybe we can just put it in a new line, save it, and yeah, and this looks a little bit more constructive, right? So this is how you can essentially execute. Did I save this? Yeah. An arrow notation function, right? So if we check this now, we should have suppressed all of the other stuff. There is an error. So something is wrong. Did I suppress anything? Yeah. So I need to suppress this as well because we're not using that anymore. So here you can see that the result is 5 plus 6, that is 7, right? A thing to note, and again, did everybody get an understanding of how the arrow notation works? Can I get like a thumbs up or something like that?
Yeah, it makes sense.
Okay, all right. Okay, so you need to practice this because we are going to be using this very frequently when it comes to moving on to not just plain JavaScript, but React.js. We are going to write a lot of these function declarations using this arrow notation. So again, understand the generic idea behind it. You have a first bracket, then the arrow syntax, and then you have the body of the function. This is all there is to the declaration part of it. If your function returns something, then you assign that to, let's say, a label or a container similar to this. And anytime you want to call or execute or invoke this function, you take the container's label, okay, or whatever that variable is that is storing the value as the name of the function. And then within first brackets, you provide the arguments to the function. That's all there is. So do not get confused by this structure, right? Think of it and compare it to the way we worked out the ternary operator example, and then you can understand that it is pretty similar to what is happening there, right? And the whole purpose of doing this is to kind of make the code base a little bit more cleaner, a little bit more compact in nature, right? So that is how we want to write our function statements, okay? So that is all there is to functions that you have to kind of keep in mind at this point of time, right? Then we need to come towards arrays. Okay, so let's go back, loops and arrays. So we cut this, okay, come down here, and then work with loops and arrays. So we will talk about arrays first. Okay, so if you remember from our basic programming, arrays are represented using these third brackets, okay? And arrays are mostly a collection of similar data types that are stored in a continuous fashion. That is the definition of arrays that we are familiar with from stricter language models, right? Well, not stricter language models. It is actually universally applicable across all languages because it's the data structure itself and not language dependent as such. You can change the composition of the values by creating things like array of objects, because within the objects itself, you can put different types of, member variables, which can have different data types. But at the end of the day, the array is a composition of objects where objects is the similarity in the data types that it is storing, right? So the first way in which you can create an array, and it is a little bit in JavaScript, and it is a little bit less frequent. Wouldn't say obsolete, but people don't use that quite often. So let's say if you want to create an array of let's say colors, right? So let's say my favorite colors. Okay, so the way you do it is by, since array is a prototype itself within a language, right? It's a data structure that is coming. So you can use constructors to dynamically create an array. Okay, so that means we can use the new operator and then we can use the array prototyping itself. And then within that, you can specify all of the different colors that is your favorite. So I can simply write red, blue, and then green, since all of this is a string data type. Okay, I think I missed something here. Yeah. Okay, red, blue, and green. So this is basically the constructor method of creating an array. So now if you ever refer to, let's say, your favorite colors, and you do something like this, and you write just my favorite colors, you just call the array itself. Okay, so we don't need the template here because this is not a string value. We are referring to the array itself. Then this should tentatively show us all of the different values. So if I clear this out, if I run my program again, so here we can see we get the different values. So this first method, so I can say method 1 of declaring arrays using array constructor. Okay, the second method is what we more commonly use. So this is I can call this as method 2 of declaring arrays in JavaScript. Okay, so all you want to do here is, let's say we do my favorite soda. Okay, something like this. So here, all we do is put a third bracket. Okay, and that is the style we are a little bit more familiar with respect to the other stuff. And then you simply write all your different array initializations, right? All the initial values that you want to provide. So I can say something like Coke. I can say something like Pepsi. And then I can say something like, I don't know, Dr. Pepper. Okay, something like this. Just give a semicolon. And then this is done. So if you want to just output this, all you do is the same thing as we did for the first one. You simply write your favorite soda here, give a semicolon, end it, clear this console, node.index, and then you will get it, right? So you can do both of the methods of kind of declaring it, but more often we use this method. Okay, so this is, we can say here, I will just say use this method. This is basically the preferred way, or mostly people use this way in order to declare all of your arrays. Now, everything else is going to be kind of similar with respect to what I mean by that is, like, let's say if you're trying to refer to one of the indexes, or you're trying to extract a particular element within the array itself, then what you can do is you can put the third brackets after the name of the array. And remember, array indexes always starts from 0, right? So the first element is the 0th index. That is computer science for you. So all you need to do is, if you do 1, so that means that is going to refer to the second element of the array itself. So that is going to just return you a single value. So this is how you are going to refer to a single value. But what or where JavaScript starts to differ, and this is what I think I was trying to say earlier, is you do not need to have all string values or all numeric values in JavaScript when you are working with arrays, right? This is where it starts to kind of break apart from the other languages that we are familiar with. So let's say if you want to create a student record or student array, which consists of the values pertaining to different aspects of a student, right? Like their name, let's say their GPA, and then if they are a senior or not, something like this, if they have major standing or not, something like this, right? So if you want to create such an array, so we can say const student record, and then again, we do the third brackets that signifies. So let's say the first two things, or the first two elements of the array is going to be their first name and their last name. So we know that that is going to be a string data type. So I can write something like this, John Wick, okay? And then let's say we want to store their age. Okay, so their age is, let's say, 35. So that is going to be a number. Then let's say we want to store their GPA. So that is also going to be a number, because there is no distinction between whole numbers or integers or decimal or floating point values in JavaScript. So we can say something like 3.81. Okay, and then let's say we want to store a Boolean flag that indicates whether this student record has a major standing or not. So let's say we just say not true, but true. Okay, and then we are going to just close this. So this is accepted in JavaScript. So basically what this means is that if after this you do a CLG and simply, specify student record, save it, let's clear this. Okay, so then you can see that JavaScript is capable of creating an array where the individual elements is not the same as that of the other elements, right? So it does not have the same data type. And this kind of results or goes back to the fact that there is no data type initialization with respect to the containers that we create, whether that be a variable or whether that be an array. You can always store different values together. Okay. The other thing is, if you want to kind of, let's say, insert an element within the array, then there are some methods that is quite handy in order to work with the array. So let's say if you want to insert something at the beginning of the array, right, or the end of the array, or if you want to remove something at the end of the array itself. So let's say I want to take this array that I have created, the student record array, and I want to remove the last element. For whatever reason, I want to remove the last element. So what we do is, instead of treating this array as an array, we treat this array as a stack, right? As a stack data structure. If you guys remember stack was like this bucket container where the idea was first in, last out, right? So that is what the stack data structure is. So stack has two different methods. One is push, and the other one, that is for insertion, and the other one is pop for deletion. So when you do a pop from a stack, then it's just going to take the very top element that is present in the stack, and then it is just going to remove it from the stack itself. So the same concept is kind of implemented here, that if you treat this array as a stack, and if you want to just remove the last element, then you are going to just pop it from the array itself, right? So that means, what if after this I do the name of the array, and it's an array method, so we will have to use the dot operator in order to kind of use it, and it's a method itself, so it has to have its own first and second opening and closing first brackets. So if we pop this, essentially we should just see until 3.81. So here you can see that the last element was basically popped, right? But if you want to push something back at the very last location of an existing array, so let's say after we pop this, we want to push something else altogether. So we are going to use the method called push, which is the opposite of pop, right? And within push, it takes a parameter. Okay, it's not an empty parameter declaration like pop is. Pop is empty. You don't provide any arguments here. So here you can provide probably their favorite coursework. So we can say web and mobile systems. Okay, so let's say if you want to write this, something like this, right? So now if we run this, we can see here that the first statement here on line 88 that removed whatever the existing value was from the very end. Then the next statement, which is line 89, using the push method of arrays, inserted this input or this parameter to the very end of the array. So remember, whenever you have to work with just the last position of the array, the index n-1, right? Then you use either pop or you can use push, right? So what is important is then kind of how do you work with the array when, let's say, the information that you need to insert is not at the end. So we learned that if you want to insert something at the very end of the array, the last index, we can simply use push, right? If you want to remove something which is at the very end, we can use pop, right? But what happens when you want to insert something, let's say at the beginning, right, instead of the end, right? So in order to do that, there is also another ready-made method, right, or a method that is available for our utilization, which is known as unshift. Yeah, unshift. So what you do in unshift is, of course, you provide a parameter just like you did in this. And let's say you want to provide an ID. So we can do something like E101, some ID that is this, okay, employee 101 or something like this. So if you do this, then this will essentially put the value that you provide as a parameter within the unshift method at the beginning of the array, right? So you have to keep in mind that you can delete or insert at the very end of the array. There are ready-made methods for that with the array prototyping. And then if you use unshift, that is going to put it at the beginning. Now a question for you, or a practice exercise for you, how would you insert something at some particular index within the array? Can you do that? You should have done this operation when you were doing the data structures. But as a self-exercise, try it out that instead of putting it at the beginning or at the end, how do you code for putting it somewhere in between if an index is given? Let's say instead of saying, if I tell you that insert an element between the indexes 3 and 5, 3 and 4 of your array. So that means whatever the fourth element is will become the fifth element of your array. So try that out as a self-exercise. Try that out and see if you can work with this. All right. There are also other methods that you can use. So if you want to know if a particular method is an array or not, all you need to do is this. So you can do console log, and then after that, you can use the method of array itself, or the array object itself, which has a method called isArray that checks that the parameter that you pass to this method is an array or not. So if we do student record, save it. So this is just simply going to return a true or false value if you execute this. Okay, so this is going to return you true. And if we use something else, do we have some other values here somewhere? Let's say we use this one, user age to vote, but you get the idea. If I change this to user age to vote, which is basically a variable and not an array, then if you run this, then this is going to return you a false value, right? So you get the idea of what this can essentially do for you. So I'm just going to, right? The other thing is to get an idea of the size of the array. So if you want to get the size of the array, then you use the property, not method, but property of the array object, which is called length. So if I do something like this, and I simply put my array name here, and I do dot length. Remember, this is a property. This is not a method. So we don't need the first brackets around or towards the end of the length itself. Okay. So if we run this now, then this is going to, again, I forgot to save this. Okay, then this is going to return me the total number of indexes that is present here. So if it returns me the size being 6, then the indexes is going to run from 0 to n-1, which is 5 essentially, right? So that is the basic stuff that we are familiar with. Again, and the last thing that you can do is kind of concat two arrays together. So let's say if we have an array of, let's call it letters 1, okay, and let's say this is going to be an array of string values, so A, B, and then C. Okay, so let's say we have this, and then we copy this, and then we do letters 2, and then we do D, E, and then F. Okay, so this is what we have here. And what we want to do is basically we want to merge these two arrays or concatenate these two arrays together. So that means we want to create a resulting array. So we can say constant letters, okay, letters 3. Okay. So now we want to build a new array by combining this array first and then concatenating it with the next array after that, right? So what we do there in that particular scenario is we take the first array that needs to come first, and then there is a method for the arrays that is, as you can see here, concatenate itself. So this is a method. So that means this will have the first opening and closing parenthesis, and inside of the parenthesis is where you will have a parameter. So if you have guessed it already, the parameter that you need to have here is basically the second array itself. So now if you create this, and then let's say put a console log and then do letters 3. Okay. So now if you do this, then you essentially see a resulting array that is basically a concatenation of the two arrays that we have declared before, right? So let's run this again. So here you can see that it combines it together. So if you're trying to combine multiple arrays, then this is the easiest way to kind of do this, right? So with this out of the way, we can start working with loops at this point of time, because essentially when you know the arrays, you can essentially loop over them, because that is one of the ways or the easiest ways you can traverse over arrays, right? So let's talk about loops now. Okay. So when you're working with loops, for loops in particular, so I'm just going to simply write for loops instead of saying just loops in particular. The syntax is pretty simple. Okay. So, and it is quite similar to what you have seen before. So you would have for keyword, which is a reserved keyword, then all of the declarations of for, which means the initialization, the first portion is the loop control variable. The second portion is the condition, which kind of checks whether or not to continue the execution of the for loop. And then there is the update of the loop control variable, which is the last portion of the for declaration. Okay. And then within the body, you essentially write the logic that you want to execute with respect to the for, right? So here we can have index is 0, index is less than. Now you can see here that this is the reason why we wanted to do arrays first, because even in the prototyping itself, it takes this. So we can take our letters 3 array, take the length. Again, remember the length is a property. It is not a method. So there is no opening and closing brackets here. If you do not update your loop control variable, there's a good chance you will end up in an infinite loop, and you don't want that. So here you can simply write, let's say, a custom message here. So the first letter, or we can do this, and then the index +1, because we don't want to start from 0, letter is, and now we want to refer to the value that is present in index +1 itself. So what we want to do there is we want to go again back to our $sign and curly braces. And then within this, we are going to write letters 3 within third brackets. We are simply going to specify index. Okay. So if we run this, if we execute this, then this should give us all of the letters one by one. So let us give it a shot and see if we get what we wanted to. So here we can see that letter 1 is A, B, C, D, and this is how you are going to write a simple for loop. Now, if you want to rewrite the same thing using the while loop, okay, and this is going to be pretty simple as well. There is nothing there. So the only difference is that you can see here in the while loop, you do not have a loop control variable that is declared with the condition itself, right? So the condition is where you have to do it. So here I have to first declare a while loop control variable outside of the loop body first. So I can do something like this, LCV, that stands for loop control variable, and I can assign that to a value of 0. Okay. And what I can do here is while LCV is less than letters 3 dot length, because that is the condition that we are trying to implement here, right? And then all we want to do is just copy this again and put this here. But remember, we still need to update our loop control variable somewhere. So after or before we exit the body of the while loop, we are going to take LCV and then we are going to add a plus plus, right? So that can essentially, we are using the unary operator. I believe everybody is familiar with the unary operator. But if you do not want to use the unary operator and you want to use a bigger code base, then you can do something like this. Okay. So this is basically, you wouldn't go into the problems of using a pre-unary operator or a post-unary operator, because those have different logical consequences and stuff like that. So essentially, this is how you can write the same thing in the while loop format. Okay. There are certain other things that you need to know with respect to like creating iterators over the for loop. So there are different ways in which you can write these for loops again. So if you want to, let's say, loop over the for off loop, right? So what you can do is you can have for, and then you can create an iterator object. So you can do let, and then you can create an item here, and let's say iterator variable. Okay, and then this is the syntax, what we call as the for off looping, right? So what you can do is that, let's say you have an array or you have an object literal. We have not covered object literal yet, but object literal you can think very similar to an array, but it doesn't have that continuous data structure. It is more of a mapping of a key value pair, right? So that is what object literals are. So if you want to create an iterator, So if you are familiar with that in other languages like Java, this also is supported, that instead of creating a counter and then running over the array or the object literal, the syntax is basically for off. So the for off is the way of JavaScript's way of creating an iterator, right? So this will allow you, so if you do this, let iterator off, and then you specify something like letters 3, then this will allow you to kind of loop over all of the different elements of your array, right? So you can just kind of write whatever logic that you want to create. So remember, this is something that you can use for arrays and object literals. Okay, at this point, I'm not writing the same body again and again, but you get the idea. This is subjective in nature. And then you can kind of use this any way you would like to. There are also certain things that we call as higher order array methods. And this is something that we will use a little bit, okay? Not little bit, depending on the use case scenarios, we will see usages of these higher order array methods. So this is basically, instead of writing in a traditional way, certain logic to loop over, let's say, arrays, or let's say arrays of objects or object literals, we have a more abstract code base that helps to kind of achieve that same logic. So think of it this way, like, oh, you have a traditional way of writing a function, but you can write that same function as an arrow notation that reduces the amount of code that you have to write, right? Similarly, you can write a chain of an if-else-if statement, right? Or you can replace that with switch case statement, where the execution is a little bit faster. So these higher order array methods, okay, are basically logic that are embedded within certain syntaxes, which if wasn't present, then you would have to write the whole thing by yourself, right, from scratch, and that will increase the size of your code base, okay? So there are three different higher order methods that we typically come across, right? So we have what we call as for each, which is again an iterator based method to go over the array. The second one is known as map, okay? And then the third one is known as filter. These are methods, by the way. These are higher order array methods. So that means this has to be called using the dot operator. Please keep this in mind. This is not similar to like the for off, or this is not similar to like a while loop or a for loop. These are all array methods. So just like we saw here in all of the other array stuff, like when we were calling this where did it go? This pop, this push, this unshift, or using this length, which is a property. It's not a method, but you get the idea. So these were how we were calling these methods. So these three different things, okay, or constructs are basically methods. So you have to remember that they go in conjunction with an array. They don't exist in itself, right? So we need to basically have something like an object literal or something like an array in order to kind of use this, all right? So what map does, the for each is basically an iterator, okay? It will iterate iterator. It doesn't do much more than that in terms of functionality. So the map creates a new array from an existing array based on a condition. Okay, we are mapping an existing array to a new array. That new array could be larger in size, it could be smaller in size, it could be the same size, but it could be processed. So for example, if you want to think of a use case scenario, let's say you have an array, which is 2, 4, 6, three numbers, 2, 4, 6. So now you want to create a new array by adding or multiplying each value within this array with 2. So you want to double all of the values that is present, right? Or let's say these are the salaries of different employees, and then you want to apply a year-end bonus to all of these individual salaries, right? So let's say you want to increase this value by 1.5%. So what happens is that if you use the dot map method, then you can create a new array that is map the existing array to a new array, and then apply whatever logic you want to apply during the mapping process. So like you can do this as 4 times 2 becomes 8, 6 times 2 becomes 12. And this is the new array that you can create. So remember, since map creates a new array by applying certain logic, and that logic could be anything, all right, this is always going to return an array as well. So that means you have to kind of store the value somewhere, right? We will look into the implementation side as well. Filter, on the other side, instead of mapping, it creates a new array as well, but by reducing the existing array based on certain conditions. So that means, let's say for an example, if you had 2, 3, 4, 5, 6, 7, right? And now you want to filter this array that you have in front of you by creating a new array, or the resulting array should be an array that consists of only even values. So if you filter it, and if you know how to write the logic of identifying even and odd numbers, which you should, right? You can think about it for a second. It's a single condition, right? So after the filter operation happens, this should return you a new array of 2, 4, and 6, because that is it. And a good thing about these higher order array methods is that you can chain them with each other. So that means you can take the output of one of the higher order array methods and you can plug it in as the input for the next higher order array method. So that is what we mean by chaining different method executions. So that means I can take the output of this filter, and then on top of this, I can do a dot map. And this dot map will kind of double all the values that we saw here, and this will return us this array here. So this is what we mean when we talk about chaining different kind of operations, right? So we will kind of stop here for today. All we need to cover in the basics are basically the implementation of this for each, map, and filter, and then go over object literals, okay? Because we need to kind of filter this out. It will be a good item or a good exercise to learn it with object literals, and classes, which basically means we are going to look into object-oriented programming a little bit with JavaScript. And after that, we will start our first project or first demo, whatever you want to call it, which is the calculator app for DOM manipulations. And as we move forward with it, we are going to learn more about it. So we will cover this in the upcoming class, which is on Thursday. And please remember that this week's Thursday class is going to be online. Okay, I will send out a notification again on Moodle, but we will not meet in person this week, Thursday. We will meet online, and we will do it over Zoom again. Okay, so I'll stop the recording here. And if there is any lingering questions, I will take them at this point of time.